Hey everyone, and welcome. We're diving into one of the most exciting fields in tech today, the Internet of Things. So, if you're an aspiring developer or you're just curious about how our world is getting smarter and more connected, you are in the right place.
Now, let me ask you a couple of questions. What if a hospital bed could know you're about to fall and call a nurse before it happens? Or what if a factory could actually predict its own future breakdowns? This might sound like science fiction, but it's not. These are real problems being solved right now with the Internet of Things, or IoT.
So what is IoT really? At its heart, it's actually pretty simple. It's about taking everyday physical objects, the things, and giving them a digital voice by connecting them to the internet. This connection lets them gather information and talk to each other, basically making them intelligent.
So yeah, at its core, IoT is the bridge that connects our physical world of objects with the digital world of data. It's all about taking ordinary stuff and making it extraordinarily smart.
Okay, to really get a grip on how this all works, we're going to follow a single piece of data on its 5-step journey. We're going to track it from a physical sensor all the way to your screen. It's a pretty cool process.
All right, so here's the roadmap for our data's journey. It starts with a physical interaction, moves through some local processing, travels across networks, gets analyzed up in the cloud, and then finally it shows up on a screen for a person to see. Let's break each of these down.
Okay, step 1. Everything begins right here, with the system's senses and muscles. Sensors, well, they're the senses. They gather data from the world around them, like the temperature in a room, the vibration of a machine, or even a patient's heart rate. Then you have actuators. They're the muscles. They take action based on commands, like flipping on an air conditioner or sounding an alarm.
Next up, the data hits what we call the local brain. See, instead of sending every single bit of data to the cloud, which can be slow and expensive, edge devices do some of the thinking right there on site. Then, gateways act like a secure door, collecting data from lots of sensors and sending it on its way.
So, how does all this data travel? Through the nervous system of IoT, connectivity. This can be anything from short-range stuff you already know like Wi-Fi and Bluetooth to long-range cellular networks like 4G or 5G. This is the invisible web that makes it all work.
After that journey, the data arrives at central command, the cloud. This is where massive amounts of data, we're talking from thousands, maybe millions of devices, get stored, organized, and analyzed. This is where powerful algorithms spot trends, find problems, and turn all those raw numbers into real, valuable insights.
And finally, the journey ends at the face of the system, the application and the user interface. This is how we, the humans, interact with all that data. It might be a dashboard a factory manager is looking at, or maybe it's the app on a doctor's smartphone that shows a patient's vitals in real time.
Okay, so you've seen the whole 5-step process, end to end. Now, for the fun part. Let's talk about the skills and the hardware you'll actually need to start building these systems yourself.
What makes building for the IoT so unique is that you're blending two totally different worlds. You need hardware skills to work with the physical things, the actual circuits and sensors, and you need the software skills to handle all the programming, the networking, and the cloud stuff that makes them smart.
So, let's dig into those essential software skills. You'll need embedded programming for the devices themselves. You gotta know your networking protocols, like MQTT, which is just a super lightweight way for small devices to chat. Of course, you'll need to be familiar with cloud platforms like AWS or Azure, have some data analysis chops, and crucially, understand security from day one.
And look, getting started with the hardware side of things, it's not nearly as scary as it might sound. These 3 boards are, hands down, the best places to start. The Arduino Uno is a classic for a reason. It's simple and the community is huge. The Raspberry Pi is basically a tiny computer for when you need more power. And the ESP32 is a fan favorite because it's cheap and has Wi-Fi and Bluetooth built right in.
All right, we've talked theory, we've talked tools. Now let's see where the rubber meets the road. We're going to look at some seriously high-impact examples in 2 huge industries, healthcare and manufacturing.
Now, you might think IoT is just IoT, right? But the challenges are completely different depending on the industry. In healthcare, or the Internet of Medical Things, the absolute top priority is patient data privacy and security. That means dealing with strict rules like HIPAA and GDPR. In manufacturing, the industrial IoT, the main focus is on rock-solid reliability and figuring out how to connect to old machines that were never meant to be online.
The impact in healthcare is just profound.
We are talking about monitoring patients from the comfort of their own homes, smart wearables that can catch health issues early, smart pill bottles that make sure you take your medicine, and fall detectors that can literally save a person's life.
Just think about that for a second. This isn't just about logging data. It's a fully automated system that connects a life-threatening event directly to the doctor who can fix it in an instant. That is an absolute game changer.
Now, over in manufacturing, it's all about efficiency and safety. The #1 application is predictive maintenance, using sensors to predict when a machine is going to fail before it actually does. But IoT is also used to track assets in giant warehouses, automate quality control, and slash energy bills.
And this is the whole key, right? It's about shifting from being reactive, waiting for something to break, to being proactive. Instead of a factory shutting down for days, a simple sensor gives an early warning. This saves millions of dollars in downtime and makes the entire operation smarter.
This technology is moving at lightning speed, so let's wrap up by looking at a couple of huge trends that are really shaping what's coming next.
First up is edge computing. And hey, remember that local brain we talked about back in step 2? Well, it's getting a major upgrade. More and more processing is happening right on the device itself, not in the cloud. This is absolutely critical for things that need instant responses, like a self-driving car or a factory safety system.
And the second trend, wow, this one is even bigger. It's the fusion of artificial intelligence and IoT. People are calling it AIoT. This is where things get truly intelligent. Devices don't just collect data and follow rules anymore. They use AI to understand context, learn from patterns, and make their own smart decisions. Think of a smart home that learns your habits instead of just following a schedule.
So, there you have it. We've gone all the way from a tiny sensor to the massive cloud, we've looked at the tools you need, and we've seen how this stuff is literally saving lives and transforming industries. You now have the map. The technology is more accessible than ever, so the only question left is, as everything gets connected, what are you going to build?